Have you ever wondered how a massive ship made of thousands of tons of steel can sink on purpose and then just pop right back up to the surface? Well, today we're going deep underwater to figure out that exact puzzle. I mean, really think about it. We all know what happens when you throw steel in water. It sinks, and it sinks fast. So how does a beast of a machine like this not only float, but also dive and resurface with such perfect control? It kind of feels like it should be impossible, right? But the secret, well, it's all about physics. You know, the whole point of a submarine is wrapped up in this one incredible paradox. A regular ship, it's designed to do one thing, never sink. But a submarine, it's a ship that's engineered from the ground up to sink, and then, even more impressively, to unsink, all on command. It's a controlled fall and a controlled rise. And this, right here, is the absolute key to everything. A submarine's incredible ability to move up and down in the water comes from one amazing superpower. It can literally change its own density. Okay, so to really get how a sub pulls this off, we need to talk about the one force that rules everything in the water, and that force is called buoyancy. So just imagine you're in a swimming pool. You can feel the water pushing up on you, right? That upward push, that's buoyancy. It's in a constant battle with the downward pull of your own weight. And whoever wins that battle, well, that determines if you float or if you sink. And honestly, it's as simple as this. A log is less dense than the water, which gives a positive buoyancy, so it floats to the top. A rock, on the other hand, is way denser, giving it negative buoyancy, so it sinks straight to the bottom. The submarine's whole job is to be both of those things whenever it wants. Right, that's the million-dollar question. It can't just magically change the steel it's made from. So how in the world does it pull off this magic trick of becoming heavier or lighter than the water all around it? And the secret is right here. It's all about these special compartments built right into the submarine's hull, and they're called ballast tanks. These tanks can be filled with one of two things, air or water. And believe it or not, that simple choice, that's the key to the whole thing. All right, so the command is given from the bridge, dive, dive. Let's walk through exactly what happens inside those ballast tanks to make this colossal machine disappear beneath the waves. It's actually a pretty elegant process. First, large vents at the very top of the ballast tanks, they're called main vents, are opened. This lets all the air inside rush out. As the air escapes, seawater floods in through openings at the bottom. And we're talking a huge amount of water here. With those tanks now full of heavy seawater instead of light air, the sub's total mass goes way up, making it denser than the ocean around it. It achieves negative buoyancy, and down she goes. So, in a nutshell, by taking on all that water, the sub makes itself heavier than the volume of water it's pushing aside. It hits negative buoyancy and simply sinks under its own new, massive weight. Okay, so we're deep underwater. Pretty cool. But how do we get back up for some sunshine and fresh air? Well, we basically have to do everything we just did, but in reverse. We have to get rid of all that extra weight. To get back up, the sub uses huge flasks of highly compressed air stored on board. This high-pressure air is blasted into the top of the ballast tanks, and it acts like a giant, invisible piston. It powerfully shoves all of that heavy seawater out through the openings at the bottom. As the water gets replaced by incredibly light air, the submarine's total mass just plummets. And just like that, the submarine is now less dense than the seawater around it. It has achieved positive buoyancy. That upward push from the water is finally stronger than the downward pull of the sub, and it rises, nice and controlled, right back to the surface. It becomes the log again. But here's the thing. Changing your buoyancy is only half the battle. As a submarine goes deeper, it enters this incredibly hostile environment. I'm talking about the immense, crushing pressure from the weight of all that water overhead, squeezing in from every single direction. So, what does 40 times the pressure feel like? Well, to put it into perspective, it's like having dozens of elephants standing on every single square foot of the submarine's hull. The force is just immense, a constant, silent squeeze, trying to crumple the sub like a piece of paper. Which leads to a very fair question. With that kind of insane force pushing in, you'd expect the whole thing to just implode, like a soda can. So what's stopping it? The answer is just brilliant engineering. For starters, the hull is made of incredibly thick, high-strength steel. But just as important is its shape. A cylinder, or a rounded shape, is one of the strongest structures there is for resisting pressure from the outside, because it spreads that force out evenly. If there were any flat spots, they would create weak points, and the ocean would find them and buckle them instantly. So you see, it's this incredible dance between the elegant laws of physics and just pure, rugged engineering. A submarine doesn't just have to master buoyancy. It also has to be an underwater fortress, capable of shrugging off the crushing forces of the deep sea. And that makes you think, doesn't it? We've pretty much mastered this whole controlled sinking thing for the depths we operate in now. But as we get more ambitious, as we try to explore even deeper parts of the ocean, I'm talking the Mariana Trench, the basic principles stay the same, but the engineering challenges get exponentially harder. What new materials, what new designs will we have to invent to survive pressures 1,000 times greater than at the surface? Now that is the next frontier.